pulley was massless, then this string were massless, and then they were inextensive. So due to these conditions, we calculated the tension and acceleration on this string. So now let us find out the general scenario. Okay. So we have a pulley, right? This is massless and two masses. So let's say this is M1 and then the other one is this M2. Okay. So now if M1 is greater than M2, so where the where the masses will move in the downward direction, or where the acceleration would be downwards, and for which case the acceleration would be upwards, for which mass, if m1 is greater than m2. So where the for which mass the acceleration would be downwards, and for which mass the acceleration would be upwards. So Ake, Rishita, and Elham and so this question for all of you guys. If mass m1 is greater than m2, so where?
No, sir.
No, sir.
Yes, m1.
Sir,
No,
M2
sir.
is greater.
Yes,
M2 is greater than
no, no,
M1.
no. So this is okay. So I am saying I have given you that m1 is greater than m2. So now I am asking that this is not the initial figure. So this is the initial figure, right? So now I am asking that where, so it will have some acceleration. So I'm asking that for which mass the acceleration would be downwards. So
M1.
m1, right? So this would go downward, and the figure would be, don't look. So this figure, in this figure, this is appearing to be mass 2 is greater than m1, right? But I have
Yes, sir.
given, yeah, I have given you. So ultimately, it will go like this, right? Okay, but this is in here. It is appearing that this is, so whenever I give that, it is all dependent upon mass, right? So whenever I give that mass 1 is greater than m2, then for here the acceleration would be downwards, and in here the acceleration would be upward. So ultimately it will go up, right?
Yes, sir.
So okay, so you guys got confused due to this diagram. Okay, don't bother about this. Information is crucial. Which mass is greater? Okay,
Yes, sir.
so okay, so now so this part is clear. So whatever mass is greater, the acceleration will be downward for that mass, right? Okay, so this is the acceleration diagram. Now, where would be tension for this M1? Where would be tension?
Sir, tension will be at M2. It is going up.
Okay, so for M2 tension is up, and for M1 where is the tension?
It should be also up.
It should be also. So is Akib saying right, Rishita Ilham and Amna? Yes, is Akib right, guys? Yes, Rishita Ilham and Amna. Don't be silent. Whatever your answers you have, please tell. So Akib is saying that for both the cases, tension would be upwards, right?
Yes, sir.
So Rishida and Elam, Amna, What are you guys saying? Okay, you
So for the cases, tension would be downwards.
downwards. Tension is downwards. So you have this string, right? This is the string, and the mass is hanging with the string. So tension is always against the mass with which it is attached, right? So let's say that the two masses are joined like this, right? So it for this mass, it would be in this way. For this mass, it would be in this way. So it is always against the direction of the mass, right?
Yes, sir.
Okay, so this was the question. Now you know the tension and the last one. So what is the other force that is acting on this mass?
Gravity.
Gravity. Good. So gravity, so it is going down, right? And in here also the gravity is going down. Okay. So now we have to draw free body diagram for M1 and for M2. So let's say for M1. For M1, this is the diagram. So this is M1G, this is tension, and this is the acceleration. Okay. For M2, this is the tension, this is the acceleration, and this is the gravitational. Right, guys? This we know already, right?
Yes, sir.
Okay, so now I will ask, so what would be there? It would be whether it would be equilibrium or equation of motion. What would be there in this part? Yes. Will there be a net force or will there be an equilibrium for both the cases?
Net force.
Net force, right? Because both the cases we have acceleration, the bodies or the object is accelerating. So which means that whenever we get a no acceleration not equal to zero, so that is where the equilibrium point breaks. So whenever we have some acceleration, which means that we have a net force, right? Okay, so you guys tell me for M1. For M1, what would be the equation of motion? All of you guys, okay. So you start. What would be equation of motion?
Sir, first I should write F net is equal to ma.
Yeah, so F net is ma. So what would be that? So what would be that?
Sir, mg minus t.
M1G minus T equal to M. This is what you are saying.
Yes, sir.
Okay, Rishita, what about you? So this is Akib-san. Rishita, what about you? Yes, Rishita.
Sir, I think it's the same thing.
You didn't get the question.
No, it. I think it's the same.
Same answer. Your answer is also same. Okay. And Elam, what about you?
Yes, M1G minus T is equal to M.
Okay, Amna, what about you? Yes, Amna, what is your answer?
Same, sir.
Okay, so why you guys are sounding like confused? Good, very good. Very good, guys. So this is the equation of motion, right? Good. So you guys have revised well. So the first equation is m1g minus t equal to m1f, right? m1f. In all the places we have f. Good, guys. Very nice. So m1f. This is our first equation. Okay. So and for m2, right? So for m2, what would be the equation of motion? Or what would be f net?
So first we should write F net is equal to MA.
Yes, f net is equals to ma. Then,
Then M2G minus T
hmm, so both are
is
same.
equal to M2A.
Okay, both are same.
No,
So
no, no, sir. T minus M2G.
T minus m is m2. Okay, so this is Akib's answer. And
Yes.
Rishita, what is your answer for m2? Yes,
Sir, in this, the tension will be more, right?
tension is same because the string is that is what the condition are. The string is inextensible, so tension will be same, right? So both are right. Okay. Then what would be equation of motion, Rishita? So this is what you ask. Tension is more, right? No, this would be
Yes, sir.
yeah. Both the cases tension is same, right? Because this is the same as string and it is inextensible and it is massless. So that is why same tension. Because you are hanging two objects with the same string. Okay, so the tension would be same. If it would have been a massive string, right, then the tension would be different. But both the string is massless and it is inextensible. So that is why same tension. Okay, now what would be the equation of motion, Rishita, for this M?
M2G minus T equals to M2A.
M2G minus T. So now we have a disagreement, right? Okay. Alam, what about your answer?
Sir, T minus M2G
T minus M2G equal to M.
because of the acceleration.
Okay, and Amna, what about your answer?
M2G minus T is equal to M2A.
Okay, so we have what? So we have the same vote, right? Okay, if it would have been other way around, so you guys have a draw. So which one is the correct? What is the sign convention, guys? How do we write the positive or negative of a force in Fnet? What is the reference point? Yes?
Sorry, sir, I didn't understood.
Yeah, you didn't understand the question.
No, sir, what you just said now.
Oh, I'm saying that you guys have got a draw. So this is one and then this is two. So two here and two here, right? If one would have a majority, one answer would have a majority, then that would have been a correct answer. But you guys are getting the same answer or same draw, so either of you guys are incorrect, right? So I'm asking that how do you write the positive or negative sign of these forces? What is the reference that you take? Yeah,
Sir, F net is 0.
Reference. What is the reference that you take? What
So
is
acceleration.
acceleration? Right. Good. So you take the reference of acceleration. So whatever in the direction of acceleration, you take it as positive. Right. That is the sign convention, right, guys?
Yes, sir.
And whatever is against this acceleration, you take that as negative, right?
Yes,
Yes,
sir.
sir.
So now Rishita and Amna understood what should be there. So this should be T minus. Okay, guys. So and don't bother if you are right or wrong, right? So we are just learning. So it doesn't matter if we are right? We have to. So we are in a learning phase. So we can be wrong. Okay, so the second equation that we are getting is T minus M2G. This is M2A, correct?
Yes, sir.
So now we have to calculate acceleration and we have to calculate tension. So you guys have two equations, two unknowns, right? Calculate and tell me what is the acceleration and what is the tension that you guys are getting. Please calculate and tell. And very good, guys. You guys have got the almost got the right. Okay, so you guys have two equations and two variables or unknowns. So you guys have to solve for A and G. Please solve it and tell me the answer that you guys are getting. So you guys have 2 minutes and at 9:30 I'll take it. Because I want to work on your computational skills, right? So computation or calculation. Okay, so did you guys get any answer?
So I got T.
T. T is what? What did you get?
And M1G plus M2G whole divided by 2.
Divided by 2. So you got M1 plus M2 by 2 and then G. Okay.
Yes, sir.
Okay, so now let us guys check what is the answer. So we have M1G minus T equal to M1A. So we have m1g and minus m1a equal to t. So this is the t that we are getting, right, from equation first. Okay. And then from the second equation, t is what? T is m2a from second. M2a minus plus M2g, right? So we have this T and let's say this is first, this is second, this is third, and this is fourth. So from third and fourth, we can say that M1g minus of M1a, this is equal to M2a plus M2g, right? So this will go in the other direction. So this is M1g minus of M2g, and then this is M2a plus M1. So g is common, and we have M1 minus M. And then this is a is common, so M1 plus M. So a is what? A is g and M1 minus M2 divided by M1 plus M2. Okay, guys.
Yes, sir.
And now what would be it? So let us try to calculate it. So we have what? We can put the value of t in one of the equation. Okay, so let us put the value of t in one of the equation. So one is m1g minus of t equal to m1a, right? So m1, so uh, t is what? m1g minus of m1a. This is m1g minus of m1, and what was the acceleration that you got? This is g m1 minus m2 divided by m1 plus m2. Okay, so what you will get? You will get m1g minus of g and m1 square and minus of g m1 m2 divided by m1 plus m2. Okay, so if we take the LCM, so this is m1g and m1 plus m2 and minus of g m1 square plus of g m1 m2 divided by m1 plus m2. So this what we'll get? We will get m1 g square plus m1 m2 g and minus g m1 square and plus g m1 divided by m1 plus m. So this one cancels, and what we get? G m1 m2 by m1 plus. So this is the tension. Any doubt in this, guys? Any doubt?
No, sir.
I wanted you guys to calculate this part because this would have been an exercise, right?
Yes, sir.
So where did you reach, guys? Which part? Which
Sir,
part?
first part one went wrong.
Okay, first part. Yeah, because we have M1 and M2, so that's why. That's why. Okay, so you guys, please note down from here, right?
Yes, sir.
Please note down from. Okay, so I have written in So this is this is
Finished, sir.
finished. Rishita, Ilham, and Amna. What about you guys?
So can you scroll down?
Done, sir.
Is this okay? So this is a general formula. Okay, guys. Whenever you have a pulley system and the masses are hanging, so this is the general formula. And whenever you guys have noted it down, please tell me. And if you guys have a little bit of confusion, a slightest or any bit of confusion, so please ask.
Finished, sir.
Finished.
Yes, sir, finished.
Rishita and Amna, what about you guys?
Done, sir.
Finished, sir.
Okay, so now let us understand about. So up until now, we were studying the forces and the pulley system in straightforward way. So now what we do is that we have an inclined plane, right? So let's say we have this kind of a circle, right? And in this surface, you have put some mark, right? So you have up until now, what was your surface? So up until now, this was your surface, right? Now what you do is that you have put your surface like this, right? And this
Yes,
is
sir.
this is a surface which is making some angle with this horizontal, right? So with this horizontal, it is making this surface is making some angle. And what you do is that you put some what you put some yeah. So you put some something, right, on this inclined plane. This will obviously slip down, right? Okay, so this was what I wanted to tell. Right. Okay, so this inclined plane is making an angle theta. Okay. Now, can you guys tell me? So this is the mass and this is the surface. So what would be the normal reaction of this surface?
It'll go down the slope.
Yeah, so this surface will apply some normal force. So what is the perpendicular from this surface? What is the perpendicular? Is it this one, this one, this one? Which one? One, two, three. Which one is the perpendicular to this surface?
The,
You have
the third.
third one. Yeah, so Rishita is saying that the third, right? And Akib, Elam, and Amna. What about you
So
guys?
can you repeat the question?
The question is that you have this mass which is put in this on the surface, right? And now this surface is applying some normal reaction to this, perpendicular to this surface, right?
Yes,
So
sir.
which one is the perpendicular to this surface?
So third.
So Elham
Third
is,
one.
Amna is also saying third one. Okay, got the question.
Yes, sir.
So which one? First, second, or third?
Third one.
Third, right? So this is the normal reaction. Good. So this is the normal reaction, right? So this is the normal reaction. Now the at this point the gravity is acting. So what would be the angle of or what would be the direction of the gravity?
Negative.
Yeah, negative. So it will always be downwards, right? So it will
It
always
is
be down.
sideways, right?
Yes,
It is sideways, right? The object.
object is, yeah, it is put like this, right? So, but the gravity is always downwards, right? It is always downward. It doesn't care about the surface. Whatever the object, it will face a downward acceleration, downward force, right?
Okay, sir.
So this would be mg. So now you see that this was the perpendicular, right? This was the perpendicular. And this is the weight, which is mg. Okay. So this is making an angle theta with this perpendicular, right? So how many components would be there? So let's say that this surface has what is the vertical part or what is the horizontal part for this surface? Yeah,
Sorry,
what
sir, I
is
didn't
the,
understood question.
yeah, so this is the surface, right? So let's say
Yes,
that,
sir.
if this is the surface, right? So this is the vertical part and this is the horizontal part, right?
Yes, sir.
So similarly, if this is the surface, so this is the vertical part and this is the horizontal part. Understood?
Yes, sir. Yes,
So
sir.
this is making a 90-degree angle. Okay. So now you see that this mg weight has two parts. One is this vertical part and then this is the horizontal part. Understood?
Yes, sir.
So what would be this? This is angle theta. So what would be this? This mg has two components. What component would be this? What is the value? This we have done so many times, guys.
Sir, 90 minus theta.
No, no, no. So this is theta. Okay, if I say it in this way. So this is theta, this is r. So from theta, this is r. What is this part?
So mg cos
I
theta.
sin theta.
Mg cos theta, right? So Elham is saying mg cos theta. Or let's say for this case, r cos theta. So yeah, who said sin theta? Amna, did you say? Yes.
Yes, sir.
Okay, so Amna is saying r sin theta. And Rishita and Akib, what about you guys? So we have this vector,
So
So
right?
can you
the
show the
down will be
diagram
cos
which?
theta.
Yes.
So can you show in the diagram which line you're talking about?
Yeah, this part. So the angle with which it is making. So this is theta and this part, right?
Yes, sir. Yes,
So you said it that this is mg cos.
yes,
Okay.
sir.
Yeah, Rishita and okay, what about you guys?
Cos theta, sir.
Mg cos theta.
Cos theta, sir.
Mg cos theta. So now you see, now we have a majority, right? So in the previous case, we didn't have any majority. So yeah, we want to change the answer.
Yes, sir.
Yes. So whenever we write any component which is making an angle theta, so this is always r cos theta, right? And the perpendicular one is r sine, right? Understood this part, Amna?
Yes, sir.
Okay, so then we have this part which is mg sine theta, right? So does this object moving upward or downward in this direction in the vertical part? Is it moving upward or downward in the vertical part?
Downward.
Downward.
No, no, no. So vertical or downward meaning that in this direction. In this direction, does this object is moving?
Sideways, sir.
Sideways it is moving, right? On this surface it is moving.
Yes, sir.
So it is sliding in this direction, in the horizontal direction, right? So it has an acceleration in this direction. Okay. But it doesn't have any acceleration or motion in this direction. Is this part clear?
Yes, sir.
Yes, sir.
So we have to understand that when we have to use equilibrium condition and when we have to use the acceleration part or F net part, right? So in the horizontal way, in the horizontal direction, we will use the second law of motion, right, which is F net. And in the vertical part, we will use the equilibrium condition. Is this part clear, everyone?
Yes, sir.
Yes, sir.
So now let me erase everything and draw the diagram again because I have made a mess of this diagram. So let me draw the diagram. We have this one, right? Inclined plane. This is theta. This is some mass. Okay. This is some normal reaction, right? This is our, so let me write normal reaction, then this is mg, it is making an angle theta with this. This is mg cos theta, and then this is mg sine. And this object is sliding in this direction, right? So it has acceleration in this direction. Okay, so now, yeah, so now let us write all the equation or free body diagram. So we have this one, right? This is normal, and this is mg cos theta, and then this is mg sine theta, and then this is acceleration. Okay, so if I write the equilibrium condition for first case, what would be that? What would be that? So vertical
Sir,
part. Yes.
mg cos theta.
Yeah. So vertical part is equilibrium. At equilibrium. So we have upward or downward both equal.
Yes, sir.
Now the horizontal part. So horizontal part has acceleration. right? Then we will have what? So this has acceleration not equal to 0. So we have F net. So always remember this part. This is very crucial, and I have been focusing or emphasizing on this part that you guys have to figure out when we have to use this F net and when we have to use this equilibrium, right? So
Yes, sir.
in whatever direction we get acceleration, we have to use this F net. So F net is ma. So we have only one force which is acting in this way, so that is mg sine theta, right? And this is equal to a. So acceleration will be mm cancel, and this is g sine theta, right? So you see that does this acceleration depend upon the mass? Yeah,
Sorry, sir. Does acceleration?
yeah. Does this acceleration depend upon mass?
Yes, sir.
Yes.
Do you have any mass in this side?
So the bodies have mass, right?
Which which has mass?
The body.
No, no, no. So in this relation, do you get any mass in here?
No, sir.
No,
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 sir.
sir.
So both whatever object you put on that inclined plane, so all the object will have the same acceleration on that inclined plane. So that will not depend upon the mass of the object. Understood? They will slide
Yes,
with
sir.
the same, yeah, they will slide with the same acceleration. So that is what this result is about. So if you guys have any questions, this part is very important. This diagram, to understand this diagram, this is very important. And you will see so many condition of these kind of diagram, inclined plane. So if any of the thing which is not clear, please ask. Okay.
Clear, sir.
Okay. So please note down this part. I can also draw it like right. This is my inclined plane, and this is my theta, and this is the objects. This is the normal reaction. This is the mg. This is the normal, right? This is theta. So this is mg cos theta, and then this is mg sine. So this will slide in this direction. So anyway, I can
Finish, sir.
finish.
Finish, sir.
Finished. Rishita and Amna.
Yes, sir. Done.
Then Rishita and Amna, what about you guys?
Done,
Yes,
sir.
sir.
Good. So now let us do one question and then we'll start friction. So remember from this, we have to calculate the normal reaction and the acceleration. Okay, so
Sir,
yes,
sir, there will be friction also, right?
yeah, but I have, so because I have not talked about friction, right, up until now. So I assume that this surface is very smooth. So
Oh,
yeah, so I have assumed that this doesn't provide, yeah, so I will get to that. So yeah, when the surface is not smooth, it has some roughness, then there would be some, yeah, you are absolutely right. So then we'll have
Yes.
some friction, right, in this direction, not in this direction, but in
Yes,
this
sir.
direction. So that will oppose the motion. And if this friction is equal to the acceleration or net acceleration is zero, so this would be in here on. It will not slide, right?
Yes, sir.
Yeah. So you in here the friction is this, and this is what mg sine theta. So this mg sine theta will be balanced by this friction. But in here, we saw that mg sine theta is not balanced by anything, right?
Yes, sir.
So that is why it slided. But when we understand, when we will do the friction part, so then we'll say that it can be in here also. So it cannot slide at some case.
Okay, sir.
So now, yeah. So now let us do one question and then we'll start friction. So an object of mass 4 kg is put on an inclined plane at an angle of 60 degree. Find the normal reaction, and second, the acceleration with which it is sliding. Right. And assume that this inclined plane is smooth. Okay. So smooth meaning no friction. Please calculate and tell me your answer, guys. Right. So you have this inclined plane. Yeah. And this is 60 degree actually. And some object of mass 4 kg is put in here, and you have to calculate normal reaction, and you have to calculate the acceleration. So whenever you guys get any answer, please tell me. Yes, these are direct question, guys. What is happening?
Sir, doing the second part, R.
Okay, good.
Sir, I have an appointment in the hospital, so
Oh,
I have to leave early.
oh, you have to leave early. Okay, okay. Yeah, so that's okay. Yeah. What happened? Everything all right?
Not for me, sir. My mom. She's a bit sick.
Oh, okay, okay, okay. So yeah, okay. Please take care of your mom and yeah. Of course, you can. So yes, sir.
Yes, sir. I got 20 rupees.
Yes, 20 rupees. So Rishita got 20 rupees. Okay.
Thank you, sir. Bye.
Yes, Allah, bye, Rishita, bye, Rishita. Yeah. And what about you guys? Akib, Ilham, and Am?
So
Guys,
I got N as 20.
N as 20.
Yes, sir.
N 20 and A.
1 minute, sir. I'll recheck my email.
N is 20 and A. Please calculate. All of you guys calculate and tell. Yeah, this is what is happening, guys. Okay, so let me calculate and
I got A as 5 root 3.
5 root 3. Root 3, yeah. So, okay. Amna and Akib, what about you guys?
Sir, I'm not getting A.
You're not getting, and what is the N that you got?
I got 40.
40. Okay, so we have so many distinct answers. Amna, what about you? What did you get?
Sir, I am not able to do.
Yeah, what you are getting, Amna?
I am not able to do.
Oh, okay, no worries. So, let us, yeah, so what do we know? we know that normal reaction is mg cos theta, correct? And we know that acceleration is g sine theta, right, guys?
Yes,
Or
sir.
you can always draw the diagram. So you can always draw the diagram and then you can calculate. This is mg cos theta and then a and then this is mg sine theta. So in this way you can. Okay, so m is 4, g is 10 and cos 60. How much is cos 60?
1/2.
1 by 2. So this is 2, so this is 20, right? 20 Newton, right?
Yes, sir. Yes, sir.
So where did you get so how did you get a double answer, Akib?
Yes,
Sir,
sir.
Yes.
actually, I was doing the same method. Then I thought, how can I get theta? So I cancelled it and I just did
Yeah.
n is equal to 4 into 10 Newton.
Oh no, no. So this is inclined if this would have been this one, right? You have a 4 kg mass, then your answer is correct. This is 4g. So this is n, so then n is 4g. But now this is inclined with some angle, right? That is why the
Yes,
normal
sir.
reaction. So 20. Yeah, Elham, I was asking Akib about
Yes,
the
sir.
two factor. Yes. So I was talking to Akib about the two extra factor, right? Okay. Now, when we calculate this acceleration, so this is 10 and sine of 60. How much
3/2.
is so root 3 by 2, which is 5, so 5. So meter per second, right? Okay, Amna got the answer.
Yes, sir.
Okay, so you guys please note it down. Oh, Elham already did this answer. So you guys please note it down and then we do what should we do? Because Rishita left. So I will just give the introduction of yeah, I will just give the introduction of friction. Okay,
Finish, sir.
finished. Amna, what about you?
Yes, sir.
Finished.
Yes, sir.
So now let us understand about friction. What is this friction? Right. So let's say that you were so this example I have already told you guys. So let's say that you guys are driving right. You guys are driving a car. Okay. This car is very bad. So you guys are driving a car, right? And then you stop the engine. So this car was moving with a speed which is, let's say, 40 kilometer per hour, right? So what you do is what you guys did is that you just stopped the engine. So when it was moving with 40 kilometer per hour, then you guys stopped the engine. So what will happen to this car?
Sir, it will go a little bit further.
It will go a little bit further, right? So let's say it will reach here, right? So it will reach here and it will stop, right? So at
Yes, sir.
this place, let's say that it moved this much, and then the speed becomes 0. So why the speed becomes 0? Why it became zero?
Sir, because there is no force to push the car.
But inertia, so law of inertia says that whenever, whatever the speed is, so it will remain the same speed, it will move with the same speed, right? If there is no force acting on this car, right? If there is no force acting on this car, you said that there is no force acting on this car, which means that whenever there is no external force working on any system, then it will experience or then the law of inertia will act on that object, right? So if it was moving with 40 kilometer per hour, it will always move with 40 kilometer per hour, right?
Yes, sir.
So, okay, what is, if there is no force, what is happening to this car? Why it has stopped?
Sir, because there is no force to act.
There is no force to act, but whenever there is no force, whenever there is no force, then there would be, so when there is
F net
no,
zero.
whenever there is no force, which means that V would be constant, right?
Yes, sir.
So is there V constant?
No, sir. V is zero.
So why it is happening? Yes,
V is zero.
because the inertia says that whatever the speed was, it will have the same speed, right? So what is happening with this car? And this example I have already told you. So I have talked about this example, right, Elham and Amna?
Yes, sir.
Okay, so because there is actually, right, if it is stopping, which means that law of inertia is breaking. And when that law of inertia breaks, when there is some external force, right, Akif?
Yes, sir.
So this is stopping, which means that something is pulling or something is applying some force in this direction, right?
Yes, sir.
Something something is opposing the motion of this car. So that opposing force is called the friction, right? So friction is acted upon when a moving object is there, right? So whenever there is some object, right, and it has in contact with some surface, then there would be some friction, which will oppose the motion of that object, right?
Sir, it will be opposite of the acceleration direction, right?
Yeah, so it will be always opposite to the motion, right? So if it is,
Yes, sir.
whether it is moving with some constant velocity or anything, so it will always opposite to the motion of the force, opposite to the motion of the object, right? So it will try to oppose the, yeah, you are correct, acceleration or motion, right? So these tires are touching the surface of this object, and due to the roughness of this road, right? This road is applying or opposing the motion of this car in this direction, and that force is called the friction. So friction is an opposing force which opposes the motion of the object whenever they are in the contact, right? So whenever their surface is in contact, then they will experience some opposite force. Is that clear, guys? Akib, Amna, is that clear?
Yes, sir.
So
Yes, sir.
it is an opposing force which opposes the motion of an object, we should write due to their surface in contact. Right. So there are two kinds of friction. One which happens in solid objects, and the other one which happens in fluids or liquid. Right. So in solid object that is called friction, and so we have two types of friction. So one is in the solid object, which is friction, and in the fluid, it is called viscosity. Right. So this is in the solid objects. Okay. And viscosity in fluids. These are the examples of frictional force. Right. So in fluids, you guys have seen that whenever you put some object, right? So let's say you are putting some object in water, or you are putting some object in oil, or you are putting some object in jelly. So the object will go down in different way in all these fluids, right? And that is because they will experience some opposing force. Okay. So due to
Yes,
that,
sir.
yeah, due to that, so this is the example of friction in fluids. And in the solid objects, you have friction that is called the friction, right? So this has also two types. In solid object, this has also two types. One is called the so this is impending friction or right. So this is impending friction, and this is called the rolling friction. Or this is called the slide. Okay, and this has also has three parts. So this one is static friction. Then we have limiting friction, and then we have kinetic friction. Right. So these are the examples of friction. Rishita is not here. So what I will do is that I will talk about these frictional forces in detail in the next class. Right. Who got disconnected? Oh, Learnivio team got disconnected. So yeah, guys, what should we do? Should we go ahead? Should we talk about all these frictional forces, or should we stop?
Sir, your wish.
My wish, because if okay, so let us do some. So first one is the static friction, right? What is yeah? So first one is the static friction.
Sir, can you scroll up?
Okay, so you want to note down this part. Okay, so please note down this part.
Type of friction.
Yeah, type of friction. So this is rolling friction, and I am forgetting the name of what is impending friction or linear friction or sliding friction. What is that? Okay, so there is some
Done, sir.
done. And what about you guys? Elham and Akib, are you guys
Finish, sir.
Yes, sir. Yes, sir.
okay? So, what is static friction? Let's say that you have a sofa, right? So you have a sofa. Oh, let's say you have a right, and Akib is pushing this sofa, right, with some force. So at instant, let's say he started with a written force, right? So at an instant, the force, the sofa will move, or will it be there? Yes.
Sir, how much?
Yeah.
Like too
So
much force?
not too much force. So you started with okay. Who?
So
So
first it will not move, and then when we apply more force, then it will move.
yeah. So which means that whatever force we are applying, there is some opposite force which is applied by this sofa, right?
Yes, sir.
So this is in contact with the surface, right? And whatever force you are applying to move this sofa, so this sofa is also experiencing due to this surface some force in the opposite direction, right? So whenever the object is not moving, right? So that much of friction is called this static friction. Okay, and there would be some point at which the sofa will start to move. So that point will be called the limiting friction, right? So at that point when the sofa just starts to move, so that friction will be called a limiting friction, because after that point the sofa will have some kinetic energy. The sofa will have some movement. So up to that point, it will have a static friction, right? So when we apply some force to that sofa and it is not moving, so it is due to the static friction, the force applied by that sofa, okay, or the force experienced by that sofa due to the surface touching that sofa. So that is called the static friction. And is it a constant friction or changing friction? This static friction?
Changing?
Changing, right? So this is an adjusting friction. Okay. Let's say initially Akib was applying 14 Newton force, right? And this sofa is also applying some how much force? 14 Newton, right? Let's say that Akib is applying, let's say 20 Newton, right? Then this sofa is also applying 20 Newton force. At that point, this sofa is stationary. It is not moving. So you saw that at this point, the friction was how much? 14 Newton. And at this point, when we applied this 20 Newton force, the force changed to 20 Newton. So you see that this is adjusting force, right?
Yes, sir.
Right. Okay. So this static friction is an adjusting friction, and right. So when the object or the friction force frictional force experienced by stationary object, right? And it is an adjustable. Okay, and it is dependent upon. it is dependent upon normal reaction, right? And it is independent of area of contact. And it is dependent on roughness of the surface. Okay, so this mu s is directly proportional to normal reaction, and this mu s is equal to or less than this uh, this normal reaction, and then you have this proportionality constant. So this is what you call the frictional force. So I should write it as F static is directly proportional to normal reaction, and if you remove this proportionality constant, then you get so this is called the frictional constant. Okay, so this equal to sign represents the limiting friction, right? So the maximum friction, the maximum static friction at which the object starts to move, right? After which the object starts to move. So that is called the limiting friction. Is that point clear to you guys?
Yes, sir.
Yes,
Okay.
sir.
Okay, so please note down this point. Please note down.
So can you scroll down?
Finish, sir.
Done, sir.
Okay, so let's say let's take an example. So we have this object, right, and it is kept on this surface, right, and you apply some force in this direction, but it is not moving, right, which means that it is experiencing some force in this direction. It is not moving, which means that the frictional force is static friction, right? So this is static friction, and let's say the mass is m, and this is mg. Normal reaction is what? N. So this is at equilibrium. So what would be N? This is not moving. Object is not right. So what would be N?
Mg.
Mg. Right. So N is mg. Now we already know that what is the static friction. This is less than equal. Is this point clear, guys? So we'll do some questions based on this static friction in the
Sir,
next.
I was not able to hear after mg.
Yeah. So N is equal to mg, right?
Yes, sir.
And we know that static friction is proportional to the normal reaction.
Yes,
I
sir.
so I just plug in the value of N from here. So that is what I got.
Yes,
Clear?
sir. Okay, sir. Yes, sir.
Okay, so please note it down, guys, and then I will stop it here. And if you guys log into your Learnivio account, then you guys will see the active test.
Done, sir.
Done, noted. Okay, Amna and Aki, what about you guys?
Done,
Yes,
sir.
sir.
Okay, so you guys please open your Learnivio account and then log in, and then you'll find, yeah, you'll find the active test. Please take that test. Okay. Okay,
Yes,
guys.
sir.
Okay, so I'm leaving and you guys can also leave, but please complete that test. Okay.
Sir, can I ask you something?
Yes, yes, Sarah. Yes.
Sir, can you take a backup class where you explain dot product?
Dot product. Okay,
Yes, sir.
so I will yeah. So let's say tomorrow. What about tomorrow?
Yes.
So
Okay,
tomorrow,
sir.
yeah, tomorrow at 5 p.m. Let's take a backup class, and then in that I will talk about dot product. Okay.
Okay, sir. Sir, tomorrow we have the normal physics class also, right?
Yeah, yeah. So at 9 p.m. we have the physics class.
Sir, KSA what time?
KSA, okay, so 5 p.m. is
2:30, sir.
and 30 K. Okay, is that okay for you, Elham?
Yes, sir.
And Amna, you also be there. And Akib, if you want to join, so you please also be there. Okay.